Greetings everybody, welcome to the latest edition of the Physics Corner, a series of videos in which we show how to set up and solve introductory physics problems. I'm your host, Dr. Christopher Sorolla. Today we're investigating the idea of density, or mass per unit volume of substances. Now, to get a little bit of a handle on that, I want you to imagine the following fanciful situation. You're walking along in the forest and you encounter a leprechaun. He's a friendly leprechaun. You strike up a nice conversation, you have a good time, and when you're about ready to leave, the leprechaun says, well, you've been very friendly. Tell you what, I've got some gold to give you. I'm going to give you a volume of 1 gallon's worth of gold coins, pure gold coins. Here's my question to you. How much would that weigh? Is this going to be something you can easily pick up and cart off, or what's it going to be like? Now, in order to get after that, we have to do a couple of things. One is, of course, we have to investigate what it means to be a density in the first place. But also, there's a lot of unit conversions going on here. So physics, of course, as you're well aware of, tends to use the metric system, standard units. So meters, kilograms, the like. But I just introduced a gallon. And I did this on purpose because I want to be able to show again some transformations between different kinds of units. And so 1 gallon is the same as 3.785 liters, or 3.785 times 10 to the minus third cubic meters. That'll come in handy to know. Also, for our listeners, especially in the United States, which is most of you, probably the conversion between pounds, weight pounds, is 1 pound is the same as 4.448 newtons. Now, also, in this particular problem, I'm going to go and use our value of G, which we have where I live, is 9.81 meters per second squared. Now, I typically round that off to 10 for other videos, but because there's a lot of significant figures going on here, let's go ahead and do the same with that number 2 today. So, before I get started on the gold, let's ask a separate question. How heavy is a gallon of milk, or conversely a gallon of water? And for our purposes, we'll assume milk and water have the same density, which is close enough. So, what would I do in order to solve that? So, first things first, the definition of density is this. Density, which is the Greek letter rho, which in English is spelled like this, but is pronounced R-O-W. That is actually the Greek letters R. It looks like a curvy P, right? But it's not. The letter P is pi in Greek. This is actually an R, and stands for rho, or density. This is mass, this is volume, right? So the gallon is the volume idea, and the mass is what we're after. So we want to find weight. Weight, of course, is equal to mg. So if we want to find the weight, which is the question, we need to find mass from this. Take this equation, turn it around, mass is equal to density multiplied by volume, like that, right? So if I know what the volume is, and I know what the density is, I can solve for mass. So let's go ahead and do some work on that. So what's the volume of 1 gallon? So volume equals 1 gallon. In metric terms, that's 3.785 times 10 to the minus third cubic meters per gallon, right? And I know I just wrote out something I didn't need to write, but let's go with it. And that's the volume. Okay, now, by the way, if you notice something, this number, if you round up a little bit, is almost 4, or 4 times 10 to the minus third, which is to say that a liter and a quart are almost the same thing. They're not quite, but they're close. So if you want to think of a gallon as having 4 liters in it, you're not too far off. Anyway, that's our volume. Let's go ahead and work this out for water. So the mass of water, H2O, is then the density of the water multiplied by volume. Now I'm going to use the same volume for both our water and our gold, so I don't have to put a subscript on that. Water, by definition, has a density of 1,000 kilograms per cubic meter. Here's the volume of the water. And this is why I chose to set up this way. My meters cubed here cancels my meters cubed here. 1,000 wipes out the 10 to the minus third there. And it's 3.785 kilograms is the mass of the water in a gallon. Okay. Furthermore, the weight then of the water is the mass of the water multiplied by little letter g. So again, 3.785 kilograms, and g is 9.81 meters per second squared. And if I do a little bit of figuring, I end up with a number of about 37.1 newtons. So in metric units, that's what I have. Now, again, to give this a little bit of a flavor that American listeners will more appreciate, let's convert that into units of pounds. So, weight is 31.7 newtons, but it's 1 pound for every 4.448 newtons. So roughly 4.5 newtons per pound, right? Set up this way so my newtons cancel and I'm left with pounds. And I end up with, and I'm going to round off this answer here, 8.3 pounds. So this gives you a reason or a reasonable idea. If you get a gallon of milk at the store, that's about 8 pounds worth of milk. That's what it means. All right. Now, since we've done this, I don't need to do every single thing for the gold, but let's do some of that and I'll show you what happens. So the major thing, which hopefully is kind of obvious, the density of gold is much, much larger than the density of water. And therefore, everything else will be scaled up. Now, I could just simply multiply this by this factor here and be done with it, but I thought it'd be instructive to take the long way around. So if you don't mind, we'll do that. So we already know what a gallon is. Let's get the mass of the gold then. So mass of a gallon of gold. Now, AU is the elemental symbol for gold, so AU. So density of gold multiplied by volume. Notice it's 19,300 kilograms per cubic meter for gold. Gold is very dense. And then the 3.785 times 10 to the minus third cubic meters there for the volume. And when I do this, I have something about 73 kilograms. That's decently heavy. Let's turn that into newtons quick. So weight of gold is mass of gold times G. 73 kilograms, 9.81 meters per second squared. And I get 717 newtons. And last step then, to convert this into pounds for our American folks. Weight of gold, which is 717 newtons. Again, 1 pound for every 4.448 newtons. And I get 161 pounds. So, suppose you ever encounter that leprechaun. You say, well, Mr. Leprechaun, that's all very nice. Do you have a wheelbarrow? Do you have a cart? Do you have a really, really strong bag with handles at least? Because that's going to be very, very heavy. Is it something that you and I can pick up? Possibly. It depends. Depends on how strong you are. Not everybody can lift that much weight. It's a decent amount of weight. But if that's real gold, guys, it's worth it. So make sure you stretch before you lift. Anyway. All right. Technical assistance for our program is from Cindy Geltraw and Sophia Turner. Funding for this program comes from the University of Mississippi and University of Southern Mississippi. I am your host, Dr. Christopher Sorolla. Thanking you for your attention, and clear skies.